For this video, we'll be discussing dilution, and in order to have a good ability to understand this concept, you'll want to have a good grounding, in molarity, unit conversions, and what solute, solvent, and solutions are. When we talk about dilution as an educator, we are often looking for examples that are universally applicable. So when our students hear us say it, you as a student say, "Oh yeah, I totally understand what she's talking about." So I was thinking about dilution, and I was thinking about a universal thing that pretty much everybody has to do. And I thought, you know, what we should really talk about is going to the bathroom. So hopefully no one will be offended. But when you urinate into a toilet here in the United States, which if you're taking my class, you have to come to campus every once in a while, or you're in my face-to-face class, either way, means that you probably have urinated into a toilet that has water in it. So versus in other countries where maybe you have a squatty potty. So when you urinate into a toilet, your urine is concentrated, and as it enters the toilet, it enters water. And the water is causing your urine to become diluted so it can be flushed into the sewer and then out to wastewater treatment plant. And if you're a scientist or even just a mildly curious person, you might have noticed that sometimes your urine is more dilute. It's kind of a pale color if you've been drinking a lot of fluids and liquids, or if you haven't and you're kind of dehydrated, it can be a really strong yellow color. And now I can just see you thinking, oh my goodness, we're talking about going to the bathroom. But hey, everybody does it. And now you'll never forget it when we talk about dilution. So the basic idea behind dilution is that your volume of your substance is going up. Think about your urine entering the toilet bowl, the vast amount of water that's there. The concentration is going down, and the amount of stuff that you have, or the moles of solute, is staying constant. And because that's the case, we can take the molarity equation and manipulate it and so that we solve for the number of moles, and then since the moles stay constant between your dilute solution and your concentrated solution, then we just drop the moles out. And we have this dilution equation that is M1V1 equals M2V2, where each of those M's, I can get my pencil ready here, each of these M's are molarities, and each of the volumes are volumes of solution. And just in case you forget, that V is volume of solution, not the volume of water. So sometimes when you're doing one of these problems, it will ask you for the volume of water, and you'll have to remember to do an additional step. We'll do an example here in a bit. So let's look at example number 1. We have 50 milliliters of 0.125 molar glucose solution, and we need it for some reaction. And you want to know how many milliliters of a 2.30 molar stock solution will be used to make this solution that we need. So I noticed that we've got 50 milliliters of 0.125 molar, and then over here we've got a 2.30 molar, and we want to know how many milliliters of it. So this is looking like a dilution calculation. So I'm going to write M1, V1, M2, and V2 to just sort of sort things out so I can keep track of things. And it doesn't matter what I choose as M1 and V1 and M2 and V2 as long as I make sure that the substances stayed paired together. So I have 50 milliliters of a 0.125 molar solution. Notice I'm not going to change out of milliliters. Normally with molarity we have to be really careful of working in only liters, but our molarities will actually cancel each other out, and so I can leave my volume unit in pretty much any unit that I would like, as long as they're consistent. I'm given the fact that my stock solution is 2.30 molar, and I don't know how much of it I need to add. So I can say M1V1 equals M2V2, and I can solve for a V2 by dividing both sides by M2 and crossing those out. So V2 will equal M1 V1 over M2. And then I just plug in the stuff that I have. So this is 0.12, whoops, helps if I write a 2, not a 5. 0.125 molar times my volume, which was 50 milliliters. 50 milliliters, I'm running out of space. divided by my second molarity, which was 2.30 molar. Notice the molarities cancel, and my end unit is going to be in milliliters. So my volume of stock solution that I needed to use was 2.72 milliliters. My second example gives me 75 milliliters of water, and I'm adding it to 27.3 milliliters of 0.379 molar KOH solution. And I want to know the new concentration of the solution. Well, I see that I have a volume to begin with of 27.3 milliliters, and my original molarity of that volume is 0.379 molar. And then I'm going to have a second volume, which I'm going to leave blank here for just a second, and a second molarity, and I know I need to find the molarity because it's asking me for the concentration. So, question mark there. My second volume, if we draw a picture here to help us understand what's happening, I started with stock solution, and my stock solution I had 27.3 milliliters. But then, to that stock solution, I added some water. And I added 75 milliliters of water. So my total volume of solution at this point is going to be the 75 plus the 27.3. And when I do that, I find that I have a volume of 102.3 milliliters of solution. And now I'm ready to use my M1V1 equals M2V2. Since I just did the algebra on the previous one, I will use my M2, M1, V1 over V2. And then I will plug everything in. So 0.379 molar, 27.3 milliliters, and then I want to divide by the volume of solution, so 102.3 milliliters, and all of this will tell me my new concentration of my diluted solution. And it comes out to be 0.101 molar. Here's our third example. How many milliliters of water must be added to 25 milliliters of 5 molar HCl to produce a 0.15 molar solution? Well, I have, it looks like an M1 equal to 5.0 molar and a V1 equal to 25 milliliters. And I want to know the milliliters of water. We know that this V2 here is not milliliters of water, it's milliliters of solution. But I can use that information to get to milliliters of water. So that's what I'm going to solve for. And then I'm given my M2 of 0.15 molar. So M1V1 equals M2V2, so V2 will equal M1V1 divided by M2, because I just divided both sides by M2, so I could cancel out it and solve for V2 by itself. Now I'm going to plug everybody in. M1 was 5.0 molar, V1 is 25 milliliters, and M2 is 0.15 molar. So the volume of my solution, when I get done here, is 833 milliliters. Now, keeping in mind, draw a picture, 833 milliliters is all of the solution. I started with 25 milliliters of stock solution. So the question asked me for the amount of water, which is the difference between what I started with. Whoops, I don't want that to be red. Oh, sorry about that. Erase. What I want is the amount of water, which is in here. And so that would be my beginning, my total amount of solution minus the amount that I started with. And that comes out to be 808 milliliters, but I only need two significant figures, so that becomes 810 milliliters.